I said, I'm here with Rob Bellinger from Olympus America. Rob has been in before with other pieces of equipment.
Yes.
What have you got for us today?
Today we're showing the Inspector Series system. This is an integrated solution for doing particle inspection on filter media or doing inspection on metals for non-metallic inclusions. This being an integrated solution has your microscope system for the high quality magnification and direct lighting onto your part and samples, with the integration of the automated solution through the software and motorized staging capabilities. This will allow for automated inspection to increase your time for scan, so where somebody doesn't have to be in front of a tool for hours at a time inspecting these things. The reproducibility is also the big improvement for the automated system. It's going to count the amount of particles consistently.
Well, let's actually, let me jump in here. So tell us exactly, what are they actually doing? When you mentioned counting particles and so forth, what's actually going on the shop floor?
So a lot of manufacturers of parts or components, or even manufacturing of larger hydraulic systems.
Okay, so machine parts,
even down to very small scale, are very concerned with cleanliness. And the cleanliness will relate to particle wear over time and their reproducibility of a part and their longevity of parts. So what they'll do is actually cleanse the part or run like an oil through the mechanism and actually run it through its extent if it's like a hydraulic ram. And they will collect that rinse fluid or oil, and they'll run it through a filter media in this case, and the filter media will trap any particulates. These particulates could be dirt, fibers, or even sheared off metal fragments.
So basically they want to characterize how much junk there is left on their part, and this product right here will count and give them some sort of knowledge of how much dirt there is on the filter, right?
Exactly.
And this used to be a manual process, somebody sitting at a microscope and counting things.
For years, yes, they would have to check their quality, and it would be a manual process, so you would get a person that would start in the morning and start counting filters all day. So they found over time that counts would vary. Even you'd be sharp in the morning after your cup of coffee, but when 4:30 in the afternoon comes,
there's a lot fewer particles.
Yeah, a lot fewer particles, and they're rushing
there's only
things.
3, time to go. All right.
The thing about an automated system is it can take that person and free them up to do other jobs, and while it does the scans, it can do much more repeatable scans on the same kind of filter medias.
Well, step us through it.
So here we have our automated inspection software, and we're scanning a filter media, and it's meant for a simple interface, so where it can be reproducible and easy to use for multi-lab and user environments. It's a big button workflow, and really the operator will place their sample on after it's been processed, the filter or maybe a metal sample. They will select new. What this allows them to do is input information about the sample. This could be the rinse fluid that they used. This could be the manufacturer of the component itself. They might actually be rinsing fluid over something they've gotten from a supplier to check its cleanliness once it's arrived. It also tracks the examinant, so it can be traceable back to who ran the parts. Then they can even put in identifiers like part numbers to later on search and find this information even in months down the road if they needed to pull the data back up. All this gets inserted into a database, and all of the data that's scanned and captured here is always archived into that database and later can be pulled out. They work down the button list, and really once it's all set and, on the microscope and ready to go, they just hit start scan. This will allow the system to automatically scan the filter paper, in this case what we're running, and it's going to have a live image detecting the particulates on the surface.
So this is the live image on the screen. Do we have a shot here of the maybe the microscope in action here as well?
Yeah, and you can see the motorized stage processing the scans, and the microscope is doing this all on its own. At this time you could walk away, get your cup of coffee, and if you see our stage, it has multiple filters as well. So some of our larger systems can hold up to 9 filters, so they could preload all these, do the work, start the scans,
and the stage would automatically rotate over to the next, or move over to the
next filter and keep scanning, and it will separate all the results individually. When it's done, it's going to go back and scan and take pictures of the largest particles. And that's what we designed we set up our process to begin with, to set up to scan the 10 largest particles.
Okay, so what you're saying is it goes through, it scans the entire thing, it's collecting all the data on whether stuff is good or bad.
Yep.
Then it goes back and it takes a picture of the 10 largest particles?
Yeah, that's what we set up the settings to do, the 10 largest. You could set it to do 0, where it won't take any pictures, or you can set it to 100, and it'll go back and capture the 100 largest particles. And what I mean by largest, this is whatever measurement value the customer is being trying to adhere to.
So they specify what they mean by large.
Their quality standard. So this will be maybe an ISO standard, which we have a lot of predefined ISO standards in the software, or the customer can customize their own standard. And when it's finished, what we'll have on the screen here is the standard that the customer is adhering to, and that will be showing down here as far as their binned out classifications. So the standard will say certain size particles, you can have a certain quantity, so they'll classify those. And the software will give a quantity count here. What's really nice about the software as well is the customer can put in their approval, their pass-fail rates. They can say, we will allow so many particles to go into a certain class range, but if it goes over that amount, it's going to fail. And if it's a quick visual prompt here, if the part passed or failed.
Okay, so in the upper right quadrant here of the software, we've got, this is basically a histogram.
Histogram of the particle counts and quantity.
These are the actual particle counts binned out.
Yep,
okay,
this is the classification bins down here, and it shows particle counts and our approval. You can see one of them failed as far as our settings went on this filter. The other thing in the bottom left here, we have a live interactive particle map. This is where they actually created a pseudo map, mapping out every particle.
So you could zoom into a particular part.
Exactly. So we can use the mouse here, and we can zoom into a specific particle and view it on the screen here. When we click on the particle,
that little upside down.
Yeah. Question mark.
Question mark there, yeah.
So this is a fiber type material on the surface of the filter that it scanned, probably from me just handling it here, because the stage will take the live image back here, so we can view the live image through our digital camera. If we zoom out, we can go around to many other particles. I know that there was a darker one down here. So customers might be doing this overview inspection to determine if these particles are round in shape, what color they might be. Clean rooms will sometimes use an inspection system to determine the quality or the cleanliness in the clean room environment. And sometimes they're looking at color images, looking for blue jean fibers.
Okay.
Because they're not supposed to be wearing blue jeans into the clean room. So if they find too many of those, they'll do an inspection and they'll want it to take pictures of this stuff. But once they have all this data, they might want to go and collect more detailed information about the particle itself. They might want to take a look at one particle here and, oops, let me click on it. And it will define it in the list here, giving you a size of the particle, telling you a little more information about it, maybe even its roundness as far as its shape factor.
Okay.
Once all this data is collected, they'll want to show the data in a report fashion. So they're working down the list here. They'll select the report button.
And you can export, I see, as either like a PDF or a Word document, that sort of thing, right?
Exactly. So once it's in this format, you see an overview image. They could export it to Microsoft Word in a button click. This is our overview image, our actual stitched image of the entire scan. Page 2 shows those 10 pictures that I talked about.
Oh, okay, there they are.
Yep.
Okay.
And page 3 is going to have your data for your classification bins and the top 10 largest particles.
Okay.
All this data is saved to the database and able to access later on down the road if they need to go back and check it.
Now this is, looking at this, this is more of a, I would say the system is more of a software product, right? I mean, this is a standard Olympus microscope, right, with a controllable, computer controllable stage, right?
Exactly.
And the software is really the workhorse here. It's the one that's doing all the characterizing and measuring of the...
So Olympus makes quite a few ranges of microscopes. So some of the customers are looking for much larger particles, and they don't need a real high magnification scope. They'll use our smaller stereoscope systems. Okay. And it really comes down to the need of the specifications they have to adhere to. Some systems with the bigger stages and very small particle definitions need our big scope with laser autofocusing, so it's tracking as it goes. So this is kind of in the middle of the range, upright compound to detect particles down to 5 microns or so.
All right, well, Rob, appreciate it, man.
Yeah, thank you very much.
Olympus America, and this was the Inspector Series system for for particle inspection.
Particle inspection for many different industries: automotive, aerospace, even metallurgical applications.
Okay, appreciate that. Rob Bellinger from Olympus America. Thanks.